Hi everyone. I was asked how to order radicals on a number line, so I thought I'd show you guys one way to do it. There are a few, but you can do this without a calculator fairly simply, based on knowing your perfect squares. So like just as a quick review, we know that 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25, and so on. So let's say I'm trying to place root 8 on a number line. Well, root 4 is 2, and root 9 is 3. So if we're going to place root 8, it's going to be like close to root 9, but not quite root 9. So to put that on a number line, it's going to be between 2 and 3. And in fact, I can estimate like 4 to 9 is a difference of 5. And so it's, roughly 4/5 of the way-ish towards 3. It's actually going to be a little bit further to the left of that, but anyway, that's sort of beyond the scope of this. But it's roughly 4/5-ish of the way across between 2 and 3. If you want to get the more exact shape, by the way, you can actually graph y equals square root x on something like Desmos.com. And you can see the shape of the curve of the graph. And so because the square root graph is sort of curved sort of sideways like this, it's going to skew a little bit further to the left than you'd think. But anyway, let's try another one. Square root. Let's do a bigger one. Let's say it's we're trying to place root 200. Okay, I don't know exactly where this is going to be, but I can do some sort of guess and check work with a calculator or just mental math to figure out what our perfect squares are on either side of this. So let's see. I know 13 squared is 169. So that one I've got memorized. So maybe 14 squared. So 14 times 14. I'm pretty sure that's 196. Yeah, 196 root 196 is 14. And then the next number after 14 is 15. And 15 squared is 225. So the square root of 225 is 15. So root 200 is a lot closer to 14 than 15, because 200 is a lot closer to 196 than 225. So if we're placing this on a number line, so we've got 14 here and 15 here, and root 200 is going to be maybe here-ish, really close to root 14. Now the same thing is true in higher degrees. So let's say we've got a cube root. Let's say we've got the cube root of, let's do 15. So we're going to need to know some perfect cubes. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 3 times 3 times 3 is 27. Okay, cool. So 15 is a little bit, let's see, it's 12 away from 17, and it's only 7 away from 8. So it's closer to 8 than 27, right? If you just do like the difference, right? So we're going to put this on a number line. So 2 is here and 3 is here. And cube root 15 is going to be, a little bit further to the left. So maybe, there-ish is cube root of 15. Now, the other thing about cube roots is you can actually have negatives as well. So what if we'd had the cube root of, let's make it negative 100. Okay, let's see, what are my perfect cubes? So my next perfect cube is going to be 4 cubed. So 4 times 4 is 16. So 4 cubed is 64. And 5 cubed is, 5 times 5 is 25. Times 5 again is 125. So 100 is a little bit closer to 125 than it is 64. And this negative sign, we can actually just split out. And so this is a little bit different from square roots. Square roots, you can't have a negative sign. You can't get a negative from a square root. But we can split this into the cube root of negative 1 times the cube root of 100. And the cube root of negative 1 is just negative 1. So this is negative 1 times cube root of 100, which means it's negative cube root of 100. And so basically all we need to do, instead of positive 4 and positive 5, we're going to do negative 4 and negative 5. And because negative numbers go deeper into the negatives to the left, the 5 is on the left. So that's basically the only thing we change. And 100 is closer to 125 than 64. It's a little bit closer, so let's put it there maybe. And there is our cube root of negative 100. And you can do this for higher degrees as well. So if you have got a fourth root or a fifth root, you can do the exact same thing. It's just, a little bit more work to find your perfect fourth powers and perfect fifth powers, but you could do it. And then another thing to keep in mind is if it's an even degree, like a square root or a fourth root, you can't have a negative inside. Negatives inside only make sense if your degree is odd.